So every now and then I will copy a math problem out of a textbook, and I absolutely love the name of the person in this math problem. Her name's not Monica, it's Monifa, and she's running for student council. And the election rules say that for the election to be valid, at least 80% of the 900 students must vote. Monifa knows that she needs more than 330 votes to win. And so the question is, uh, in what circumstances could she win if she needs 80% of them to vote and she needs 330 votes to win? How many votes need to be cast? And of those votes, how many need to be for her in order for her to win? So we've got to write a couple of inequalities. And then once we graph those inequalities, we need to solve them. And of course, we're going to have a whole bunch of solutions here. And all of the solutions will be valid ways for Monifa to win the election. So let's start off by defining our variables. So variable number one is going to be the number of people who vote. Let's just call that X. X equals the number of voters. And then Y is going to be the number who vote for her. So Y is the number who vote for. I wonder if it's actually pronounced like Monica, but it's Monifa. Who vote for Monifa. So we need two systems of inequalities, and the systems are pretty easy for us to figure out. At least 80% of the 900 must vote. So the number of voters has to be at least means greater than or equal to 80% of 900. And 80% of 900 is 720. 8 times 9 is 72, and then we just move the decimal. So we got to have at least 720 voters. Then how many have to vote for her? Well, it says right there in the problem, she needs more than 330 votes. So Y is more than 330, not at least 330, more than 330. So these are the two things that we need to graph. Now, unfortunately, we cannot graph these on a calculator. And the reason we can't graph them on a calculator is because x is greater than or equal to 720 is not a function. Since it doesn't have a y in it, it's going to be a vertical line at 720. It's not a function, and a graphing calculator will only graph functions. So we're going to have to do this by hand. And I'm just going to do a very rough sketch here. Our x is going to be number of voters, and y is going to be number of Monifa voters. And so x, very simply, is going to be a solid line at 720. And we've got to have greater than 720. So when we shade, we're going to shade everything that is past 720. So everything over here, greater than 720. Now it's not going to go on forever because we only have 900 students. So at some point, we're going to have to draw a line. Let's do it in green maybe. Let's extend this out. At some point, we're going to have a line at 900 that says this is how many students we have. We can't have more than 900 voters because we've only got 900 kids in the school. Okay, great. So now let's talk about how many are going to vote for Monifa. So she needs at least 330. So we're going to have a line going at 330. It's going to be a dashed line because she needs more than 330. That's going to be at 330. And we shade above the line because it's more than. Yep. And of course, it's also going to cap out at 900 because more than 900 people can't vote for her either. So even if every single person votes and every single person votes for her, she's not going to get more than 900 votes. So you can see we've got this little square here This square right in the middle, let's pick a really obnoxious color to do. Let's do this sort of nasty brown color here. This square right here, that's where our solution is, right? That is everything that has more than 720 voters and, sorry, 720 or more voters and more than 330 voters. So any point that is inside that square is a possible solution, meaning that is a possible way in which Monifa could win. So I'm just going to pick a point at random that's in there. And let's assume that point is, it's got to be between 720 and 900. So let's call it 810. And it's got to be more than 330 votes. So let's say 400. This means 810 voters and 400 vote for Monifa. So that's a possible solution. Now, the trick is, this is one of those rare times where we have a system of inequalities in which we do not have infinite solutions. And the reason we don't have infinite solutions is because the only solutions that we can use here are the whole number solutions. It doesn't make sense for us to have all the possible decimal solutions in here because you cannot have a partial number of voters. In other words, the point, let's say 821.3 and 506.397, it's in there, that is in the shaded section, but would not be a valid solution because you cannot have 821.3 voters and you cannot have 506.397 people voting for her. So even though that point would be in the solution set, that would not be an actual solution to our system of inequalities because you can't have part of a voter. But within that shaded section, any whole number point that is in there is a possibility. It's a possible value that would work for our system of inequalities here. So number of voters that would vote for her, and the total number of votes cast. Anything in there is something that would cause her to win the election.